To find the direction of magnetic force on a charged particle when it is moving in a magnetic field, we use two rules. First one we use Fleming's left-hand rule and Fleming's left-hand rule, and second one, this already we have seen in the previous video, and a right-hand palm rule. Right-hand palm rule. This rule we use as it is by Lorentz force. Lorentz force when a particle is moving in a magnetic field is given by charge into its velocity into the magnetic field, where Q is the charge particle, but here Q should be with sign. This is point to be noted. It may be negative charge, it may be positive charge. For positive charge, the force will be in one direction. Negative charge, the force will be exactly in the opposite direction, where V is instant velocity. V is velocity of the particle moving in the magnetic field. B is equal to magnetic field. According to right hand palm rule, right hand palm rule, how to use this it's very important, because in magnetics, that is electromagnetics, or in magnetic field, magnetism, the magnetic field has got the direction, so we used to find the direction of force using these rules. First rule, what it says, with your right hand palm, and this is the extended finger. Extended finger should be pointing in the direction of the velocity of the moving particle. Then move this towards the direction of V, towards the direction of magnetic field, and this extended thumb will give the direction of the magnetic force. That is, we can say this one, we can write this is the velocity, and this is the direction of magnetic field. What we will do with the right hand thumb, first we will keep, because we have to go from V to B, first we will keep in V, right hand palm, and it should be oriented. It may be sometime like this, it may be sometime like this, but it should be capable of moving towards the direction of B. So we move with this. So angle between these two is theta, that is V vector, velocity vector, and we move. If we move like this, this extended thumb is outward. It means the magnetic force will be outwards. Magnetic force will be outward. This is the rule we are using. Now let us take an example here. In this example, the magnetic field is inward. That is, magnetic field is inward to the board. It is inward. In this direction, magnetic field direction is into the plane of the board. This is magnetic field into the plane of the board. And the particle, let us assume the particle is moving this way. Particle is moving this way, and this is a positive charge, because always the right hand palm rule is for the positive charge. Now this is, see, now let us orient it. This is this extended finger. First we have to use V. First V, then move it towards B. This V, see, now it is V. Where it is V? V is in this direction. V is in this direction. Now we have to, magnetic field is inside. So V is in this direction. We will move like this. So where is the thumb? Thumb is in this direction. Thumb is in this direction. For this condition, it means the magnetic force. This is for positive charge. This is for positive charge with velocity this way. Now let us repeat once again. This is the direction of velocity, and move it towards the direction of magnetic field. You get the magnetic field. The force on the particle will be magnetic forces in this direction. Suppose if you use a negative charge, if you use instead of positive charge, if you use negative charge. This is first condition. For negative charge, what will be there? Exactly whatever is the now for here, this way, this is the way, this is the direction of the magnetic field. For if it is negative charge with the same condition, if it is negative charge, the force will be exactly in the opposite direction for this condition. Okay, now we have seen for upward direction, and now let us see for the downward direction. The velocity of the particle is in the downward direction. So velocity vector is in the downward direction, and for positive charge, what is, and magnetic field is inside, second one. So now velocity is downward and velocity is downward. Right hand palm, right hand, never use left hand. Right hand palm, and the velocity, first we orient in the along the direction of velocity, downward. So downward we are facing, and the magnetic field is inside, moving inside. This is the direction of magnetic force. If it is for negative charge here, the direction of magnetic force will be in this direction. Now again we keep for the same way, and this is the velocity direction v, but here we are using negative charge. In this case, now you see the same velocity is in the downward direction, magnetic field is inward, B is inward, charge is negative. So exactly same condition, but only thing here is positive charge, here negative charge. Exactly for same condition with the positive charge, force is in this direction. For negative charge, force will be in this direction. That is, magnetic force is in this direction. So next one, let us see another example. Now the velocity is, first we have seen topward, upward and downward. Now if the velocity is in downward, now the velocity is in this direction. Let us see, the velocity is in this direction. So velocity is in this direction, magnetic field is inward. Now we have to see how to arrangement. See, first we see the velocity is in this direction, moving in this direction, and B is inward. So in this direction we will lower it like this, we will move like this. It means what? It is in the downward direction. If it is in the downward direction. Magnetic force will be, let us check up once again, the velocity right hand, velocity first we will put in the direction of velocity, and magnetic field is, so we have to move this one towards the B. Now we will tilt it like this, velocity is in the direction, we will move the thumb pointing downwards, it will be in the downward direction for positive charge. If it is negative charge, velocity is same, this direction, B also velocity is in this direction, B is same direction, charge is negative, and force will be exactly opposite to this direction. So you should not worry about this one. Now velocity is in this direction, now velocity is in this direction. Let us see, velocity is, this is the magnetic field, and velocity is this way. This is the direction of velocity. So if this is positive charge. Now what we have to do, we have to orient in this direction, velocity direction, magnetic field is inward, move it inward. It means the magnetic field is in the upward direction. For positive charge, magnetic field will be in the upward direction. Let us see for negative charge. What is the direction of magnetic field? It will be exactly downward, because for positive charge, the same condition, upward means this is up, this is down. Okay, now the velocity is in this direction, it will be in the upward direction. Now velocity is in this direction. We have seen it in this direction. Velocity is in this direction, and we are moving inward. Inward means downward direction, and for negative charge, downward means upward. Okay, these are the different conditions. We can extend to any number of example using this rule. That is Fleming. That is right hand palm rule. We can use. Only thing what we have to do, we have to move. First, we have to place our extended finger along the direction of V. After doing so, move the finger towards the direction of magnetic field, in which side it is situated. So in this case, velocity is here and it is inside. We are moving. The force is in this direction. For negative charge, it will be exactly opposite. Same way, it is downward. For downward, and it is inside. It means the magnetic force will be in this direction, and for negative charge, exactly it will be in the opposite direction. Now third one, the velocity is in this direction. In this direction, magnetic field is in this direction. We have to move towards this direction, so we will tilt it like this, move towards this. It will be downward direction. For positive, this is for positive. It will be this one, and this way velocity will be downward direction. And for negative charge, this is for positive charge and this is for negative charge. Same way, if the velocity is this direction and magnetic field is, we have to move in this direction, because magnetic field here velocity is this way. We have to move our finger inside. It is in the upward direction for positive charge. For negative charge, this is it. So this is how we find out the direction of magnetic field using right hand palm rule. Now we will find out the direction of magnetic field for the outward magnetic field. The magnetic field is in this direction, coming out of the plane of the board. So this is the direction of magnetic field. First we will take the example. If the particle is moving like this, velocity with the positive charge, always start with the positive charge. This gives the direction of positive charge. See here, in this condition here, see the direction of magnetic force is parallel to the vector containing V cross B. This you have to remember. So many questions are asked based on this fact. And F is perpendicular to velocity vector, and F is perpendicular to magnetic field vector, and work done in a magnetic field is equal to 0, and kinetic energy final is equal to kinetic energy initial, that is speed final is equal to speed initial, not velocity. Velocity changes but speed does not changes. This is all the fact already we have seen. Now the condition is here, this velocity is in the upward. Always orient these fingers in this direction of V and move it, roll it in the direction of B. So here the magnetic field is outward. Magnetic field is outward. So it means velocity is in the top side. Top. Velocity, we first keep this finger in the velocity. Now we have to move towards the magnetic field. Here we have kept it as it is, and magnetic field is outward. And what is the direction of this one? In this direction. This direction. This is the direction of magnetic field. Direction of magnetic field in this direction. And if it is velocity is in this, and it is minus q, the magnetic force will be in this exactly opposite. Plus means minus q will be exactly in the opposite direction. That's why it is insisted q with sign. And this is for the positive sign. Now again we'll take one more example. It is outside, magnetic field is outside, that is outward. Magnetic field, this is magnetic field is outward. Magnetic field is outward, and the velocity we have seen upward direction. Let us see for the downward motion for positive charge. See, this is the magnetic field. It is in the downward direction. If it is in the downward direction, and we have to move our finger towards the direction of the magnetic field, but magnetic field is outward. So we will keep like this, velocity in this direction, we will move like this. This thumb indicates the direction of magnetic field. So for this, the magnetic field direction, that is magnetic force is in this direction, because force has got it this one. Now for this, if the same condition, if it is a negative charge, we can simply write it is exactly in the opposite direction. Finished. Now let us take another example. This is the magnetic field. As it is, the magnetic field direction is same. Now the velocity is in this direction. Velocity is in this direction. Let us say for positive charge. For positive charge in this direction. So if it is been first oriented in the direction of velocity, we are orienting in the direction of velocity, this velocity, then we have to move outward. So it means this we can tilt it like this, velocity outward, downward direction. Downward direction is the magnetic force. Magnetic force is downwards for positive charge, and for negative charge it will be in the upward direction. Fm will be upward direction for negative charge. Exactly reverse. One more example we will take. Magnetic field in this direction. This is one type. Another type. This is another type. Okay. Now magnetic field, now we have seen this direction. Let us see the velocity is in this direction. Velocity. So now what we have to do, orient this finger along the direction of velocity. We have oriented along the direction velocity, and magnetic field is outward. It means we have to move this finger outward. It means this will tilt like this, we will move outward. Thumb will indicate the upward direction. For positive charge, the magnetic force for positive charge, it is in the upward direction, obviously. For negative charge, the direction of force is downward. That is, Fm is downwards. So with this help, so some cases we will find the right hand palm rule is easier to find. Application of right hand palm rule is easy. Some places we will find Fleming's left hand rule. Left hand rule means left hand FBV. FBV. This stands for direction of magnetic field. This first you orient this finger, then go for this one. Automatically you will get the direction of force.